Let me share a little bit about the background of some of our projects in silicon carbide in photonics. And typically, the silicon carbide is a semiconductor, and it's very useful for power electronics. And one of my first projects was about silicon carbide as a light-emitting material for a white LED in general lighting. And the background for that is that LEDs are much, much more efficient than the fluorescent light tube and the light bulb. So let's look at the numbers. If we look here on the screen, I show you an image of a light bulb or the wire of a light bulb. And when it's glowing using the electricity, you get about 5% light out of it. This is not very efficient at all. A better option from efficiency point of view is the fluorescent light tube. And this one can have an efficiency of 15 to 25%. And it has a little bit different color compared to the light bulb. But the bad thing is that it contains mercury. And this is not good at all. So that is sort of temporary solution for many years. And the next solution is the white LED. This is a picture of LED depicted as a bulb. And then the efficiency of that one can be 30 to 50%. So then you get out up to 50% instead of 5%. This is much, much more efficiency, and it saves a lot of energy and money, especially when you pay your electricity bills. And it's not only used for general lighting, it can also be used for art and design. And since it's so efficient, then you can have more light out of it. So in this image, we see a building in Brussels, and it changes color every few seconds. So then you can use this for this design of the cities. The background to this one is a little bit small thing, which is very efficient for sending out light. And this is the blue LED, which comes from the nitrides. And this one actually resulted in the Nobel Prize in Physics, year 2014. So Isamu Akasaki was one of the main researchers to explore this since early 80s or a long time ago. And when he discovered that small pieces of nitrides could be sending out light. And then that was a super exciting story, because in these small pieces, which you see here on the left side, they could emit light, and then it was not very efficient. So then there was research how to control this, to have larger areas, good quality, and control of the P and N type doping to achieve this one. So that's a long story. But from the same group, there is a researcher, Satoshi Kamiyama, and he said that I would like to explore silicon carbide as a light-emitting material, because when you dope this, meaning that you introduce certain elements, you can get light out of silicon carbide. And that was not really expected, but due to a certain mechanism, it can happen. And here you can actually see, in this image, you see on top, UV LEDs, their light goes down to the silicon carbide and excites it and emits light from silicon carbide. It works. It's not a dream, theory, or anything like that. There is light coming out from silicon carbide. And that resulted in a very nice collaboration with different researchers from Denmark, Germany, and other places. And we had workshops from time to time, almost every year, and met and discussed things. And that resulted in more activity related to the silicon carbide as a light-emitting material, so photonics. And then researchers in Denmark, HiNO, suggested that we could use silicon carbide as a frequency comb. And that is a EU FET open project, which means high risk but possibly high reward if the research can control the intended purposes. And the frequency comb is that when you have light, a material can split the light to several wavelengths, and then you can transmit much more information. And then you can actually have much more data which is sent out. So this is a frequency comb. It's very complicated. Unfortunately for me, I'm a material grower, so I don't need to understand all the detailed physics of these things. But we had such project proposed by Denmark, and we collaborated in a consortium. And then another project was proposed about sending light with a laser, and then silicon carbide can collect the energy and create electricity, and then you can feed drones or satellites in a distance. So this is the project rePowerSiC, which is the latest project which we have. And that is super, super exciting because it brings more people to collaborate, more researchers, and there are more ideas. And when we meet and discuss, there will be more people involved and active, and especially when the young researchers come in from the young generation, there will be new ideas for the future. So this is a brief background from the research in 2010, which was initiated at that time. And now, 15 years later, there are many interesting things happening in projects.